Hello everyone, this video we are talking about section 10.6, solving quadratic inequality, also solving rational inequality. So two types of inequalities. I try to make the video short. Maybe we are going to make 3 videos for this section. Let's look at example 1 in the notes. I'll read the requirement for example 1. Example 1, solve the following inequalities. Graph the solution set on a real number line. Write the answers in interval notation. The first question, first inequality in example 1. X minus 5 times x minus 7 bigger than 0. You see this expression contains an inequality symbol. This is strictly greater than. Or if you see less than or bigger than or equal to or less than equal to any inequality symbol, then that expression is an inequality. So this is a quadratic inequality. How do I know it is a quadratic inequality? Because if you FOIL these two binomials, if you multiply them out, you would have a quadratic trinomial on the left. Okay? So that is, we are looking at a quadratic inequality. I'm going to apply 3 different methods to solve this inequality. Method 1. The left-hand side of the inequality is a product. Right-hand side is 0. This inequality is in the ideal form already. Right-hand side is 0, left-hand side is factored. So there is a fact. If we have 2 quantities, A and B, if the product of A and B is positive, what kind of conclusion we can draw from this condition? 2 quantities multiplied to a positive number. Do we have either they both be positive, be both positive, or they are both negative? Think about that. If the product of the 2 quantities is positive, then the 2 quantities must have the same sign, either both positive or both negative. Because if they have opposite sign, for example, this one is a positive 2, this one is a negative 3, then the product of the 2 numbers is going to be negative. We understand that, right? Yeah. So this is very important. This is a very important fact. We are going to apply the fact to solve this inequality. This is the first factor, like A in what I just said here. And the pink part is the second factor. Blue times pink. Blue factor times pink factor is positive. Then we would have either they are both positive or they are both negative. We agree this fact. I applied the fact here. Do you see what I'm saying? So the blue part is like the A here. The pink part is like a B here. Okay? So now we have 2 systems of inequalities. Let's solve the first system. The first inequality, x minus 5 bigger than 0. That gives us x bigger than 0. Bigger than 5. Bigger than 5. You move negative 5 over, or you plus 5 to both sides. You have x bigger than 5. Same idea here. X minus 7 bigger than 0 is equivalent to x bigger than 7. Or the other system, x minus 5 less than 0 gives us x less than 5. X minus 7 less than 0 gives us x minus 7. How do we understand the solution set of the system? We need to find all the real numbers for x, which satisfy both inequality. We are looking for real numbers. They are bigger than 5, also bigger than 7. Think about that. If the number is bigger than 7, would the number bigger than 5 also? So the solution set of this system is x bigger than 7. Any numbers bigger than 7 also bigger than 5. And this system, we are looking for all the real numbers less than 5, also less than 7. Think about if the number less than 5, then the number must be less than 7. You see what I'm saying? So if this is a real number, so this is 5, this is 7. If the number less than 5 to the left of 5, it must be less than 7 as well. We're taking intersection. Okay, all the real numbers less than 5, all the real numbers less than 7. We take the overlapping part, we have x less than 5. As I mentioned, if the number less than 5, of course, it will less than 7. So the solution set of this system is x less than 5. So we have the solution set of the original inequality. It is a quadratic inequality. The solution set is x bigger than 7 or x less than 5. Or here is the logical connective. We need to graph the solution set. This is the real number set, a real number line. We have a 5 here, we have 7 here. The solution set of the inequality is all the real numbers less than 5. So all the real numbers to the left of 5, not include 5, or all the numbers bigger than 7, all the numbers to the right of 7, not including 7. Yeah. The solution set includes all the real numbers to the left of 5, also all the numbers bigger than 7, to the right of 7. In the interval notation, we could write the solution set as a union of two intervals. Remember, how do we define interval? Interval is defined as a piece, one whole piece on a real number line. We have two pieces. This is the first piece, this is second piece. The first piece, left endpoint, negative infinity, right endpoint 5. Both are open. We use parentheses to frame them because we always use parentheses to frame infinity. On the right, because 5 is excluded, so it's open here, so we use parentheses. Second piece, left endpoint 7. Same idea, 7 is not included. We use parentheses. Use a comma to separate the left endpoint and the right endpoint. Right endpoint is a positive infinity. So two open intervals. We use union. This notation means union. We use this notation, this connective to union the two intervals. The solution set of the original inequality is the union of the two intervals, the two open intervals. This is the first method. Second method, I'm going to copy the inequality again. It is x minus 5 times x minus 7 bigger than 0. If you know how to graph the left-hand side, so if you could, how about this? We let P of x be the quadratic trinomial on the left of the inequality. Then P of x would be x minus 5 times x minus 7. If I FOIL, I would have x squared minus 12x plus 35. Okay, and then do you remember how do you rewrite a quadratic function? This actually, P of x is a quadratic function in a vertex form. In the previous section, we have learned how do we graph the parabola, right? We know this is a parabola. Yeah. So anyway, if we graph the parabola, we would have the graph of this quadratic function like this, we could identify the two x-intercepts easily, right? The first intercept is 5, 0. 1, 2, 3, 4, 5. The second x-intercept is 7, 0, 6, 7. This is pretty very thin. Yeah, it's pretty narrow. So this is a 5, 0. 1, 2, 3, 4, 5. This is a 7, 0. You can find the vertex. And I know the parabola is gonna opens up. Suppose the vertex is here. And if we draw the parabola, we have this parabola looks like this. That's the graph of this quadratic function. We are looking for all the values for x such that p of x bigger than 0. Means what? Means we are looking for the variable, we are looking for the values of x, of variable x, such that the corresponding y value than 0. Sign chart method. We apply sign chart method to solve quadratic yin 0. And the left-hand side is a quadratic trinomial. And those two zeros, 5 and 7, divide the whole real number line. From 5 to 7, that's the second. That's my first row in the of the chart testing point. It's pretty convenient. And the sign, the name of the method is called a sign chart, right? In row 3 of the chart, I'm going at those testing point. P of x is x minus 5 times x minus 7. What I really concern is the sign, means positive or negative. I don't really need the value of the P of x at those testing point. So this is how we do that. We plug in 0 here. 0 minus 5, negative, right? So the first factor, the first parenthesis, negative. If you plug in 0 here, also negative. Negative times negative, you have a positive here. 6 here. 6 minus 5, positive. 6 minus 7, negative. Positive times negative, you have a negative. Represents all the values, all the numbers in the interval above it. It's kind of like a representative. So let's plug in 10. 10 minus 5, positive. 10 minus 7, positive. Positive times positive, we have a positive. Okay, mentioned 0 is the representative of the whole interval above it. 6 represents the whole interval above it. 10 represents the whole interval above it. If the quadratic function is positive at 0, that means the quadratic function also positive over the whole interval. So we have P of x is positive over this interval, negative over this interval, positive over this interval. And what we're looking for? We are looking for the intervals over which P of x positive. Okay, the original inequality is P of x bigger than 0. So we are looking for this interval and this interval, because over the two intervals, the function P of x is positive. Okay, so the solution set is going to be the union of the two open interval. Again, we have the same result. Okay, so I'm going to stop here and start another video.